Now, number 3 objectives. The objective number 3, in this case, we're looking at exponential functions and logarithm functions. Exponential function always has 3 parts. The first part is always the coefficient, which is always a number. The second part is a base, which is also a number. And the third part is a variable, which is a power, which is always a variable. So that's what exponential function is. In this case, a good example would be 3e to the power of x. We all know what e is. E is a number, a constant number, which is, so if I write e down, so 3 is the coefficient. E is the number, which is in this case 2.718281, and it goes on. And x is the variable. So that's a typical exponential function. Or you might write 2 to the power of x is another exponential function. There is 1 in front of the 2, which is a coefficient. So that's 1. Or you might write 3 to the power of x is another exponential function. You could write pi to the power of x, because pi is a number, which is 3.142, and it goes on 59, and it goes on. So pi is a number, 3.142, and 3.141. Let's just write it clearly. So pi is 3.14159, and it goes on. So pi is a number. And then after pi, if you're looking at number, I'll put e here. E is 2. E to the power of x is 2.718. So it's before 3. And the next number could be maybe 4 to the power of x. And then it goes on, 5 to the power of x. So these are all exponential functions. So because of that, because the base is a number, so we can call the base a placeholder, and the variable here is x. So the general expression for exponential function will be a to the power of x. You could say b a to the power of x, where b is the coefficient. So y equals a to the power of x is a general expression for exponential function, where a is a number and x is a variable. So what do I mean by variable? For instance, if I'm to plot the graph of y equals a to the power of x, let's say a equals 2. In this case, we could say a equals to 2. So what I need to do is y equals 2 to the power of x. Remember, x is a variable. What do I mean by variable? Well, if I have y and an x, like that, so I get some numbers, and I say, okay, when x is 0, what is y? Well, 2 to the power of 0, so I could actually put it here. So y becomes 2 to the power of 0, and that becomes 1. Anything to the power of 0 is 1. So next one will be when x is 1. Can you see now we're varying the value of x? We're varying the value of x to get y. So that'll be 2 to the power of 1, which is 2. So y is 2. When x is 2, that'll be 2 to the power of 2, which is 4. Y is 4. When x is 3, that'll be 2 to the power of 3, which is 8. Y is 8. So that's what we meant by a variable. We're varying the value of x, so you can take in variable numbers. When x is 4, that'll be 2 to the power of 4, which is 16. So y is 16. So the value of y, so we just draw a straight line now. just write a new y. The value of y when x is 0 is 1, 2, when x is 2, 4, 8, and 16. So then I can plot that. And if I plot that, I will get this kind of curve. So if this is my y-axis, and if that was my x-axis, so that curve will be, if this was 1, when x is 0, so the curve will go that way and then increase exponentially. So that's y and that's x. So this point here is the 0, x is 0, y is 1. That's the point there. X is 0, y is 1. So that's what we meant by a variable number. So a variable. So x is a variable because it's taking different values of, taking different numbers in to get the values of y's, and we can plot those. And that's the exponential function in that case. So when the power is a variable, we call it exponential function. So an exponential function is when the power, so I'll read it, when the power is a variable. That's an exponential function. A logarithm function, on the other hand, has the name, which is log, and the base, which is a number. So it would be maybe e, because e is a number, and it will have a level, which is a number or a variable. So I could put 2 there, and a power, which can also be a number or a variable. So that's an example. Or you could have log e 3, 2, or you could have log e x squared to power 2. So what we meant is the name is always log, the base is always a number, the level can be a number or a variable, and the power can be a number or a variable. So that's how you write logarithm. And these are the examples of logarithm. And in comparison, and we mentioned earlier that a logarithm is used to solve exponential functions, and exponential function is used to solve logarithm, in the sense that we have y equals a to the power of x, and when we take log of base a on both sides, because the base of the exponential has to be the same as the base of the log in this case, so we take log base a y will be equal to log base a to the power of x, and then using the power law we came to conclusion that that's log of base a y becomes x log of base a, and log of base a is 1, so that becomes x, and that's what log of base a y is. So that's the relationship between exponential function and logarithm. Just to finish that off, y equals a to the power of x is also written as x equals log base a of level y. So those are the relationship between the exponential function and logarithm.